Brilliant. Over to you, Nathan.
Cool, thank you. Right, just waiting for this one to update as well. So firstly, I just want to say thank you to the DevOps team for inviting us to speak at the event. You know, community is really important, and having events like this really keep this community alive. So, you know, thank you guys for the opportunity. However, I am a little bit disappointed. And I'm disappointed because I'm here tonight having to talk about infrastructure pipelines. And it's nearly 2025, and it feels like this should be a solved problem by now. But it's not, so we're going to get into it. As a consultancy, we get the opportunity to work with a number of clients, and we go in and do DevOps maturity work and helping them improve their maturity. And part of the work we do is around infrastructure pipelines, having a look, seeing how we can improve. And we see issues all the time, even in 2024, late 2024. So tonight, we're going to fix it. This group in the room, you're going to go and evangelize, and you're going to fix the problem. And I'm going to share what a gold medal infra pipeline looks like if infra pipeline building was an Olympic sport. So that's what we're aiming for. So I'm Nathan. I've been building enterprise cloud platforms for 14 years. I'm a managing consultant at Daemon, and I've been working with our sort of biggest clients for about 6.5 years now, helping with this sort of stuff. So what do we mean by pipeline? I think it's quite easy to sort of explain. It's all the steps to get our code from local to production. And for me, there's a couple of really good qualities, or the three qualities I expect in a good pipeline, is that it's automated. We want it to automatically drive quality into our work, and it needs to be thoughtless for our teams. You know, they need to know that this is happening to them without them realizing it. A lot of the talk tonight will focus on these two sort of tools, but a lot of it is also applicable elsewhere, generic stuff, right? So please, I'm hoping that everyone takes something away from tonight. So we're going to move quickly. We're going to start with a bronze medal pipeline, and then we're going to build ourselves up, add more and more bits. My goal here is just to share a number of tools that we typically like to, we see work well, into pipelines that work really well. And hoping that some of you guys can take that away, build that into your pipelines starting tomorrow. So let's start with bronze. So for the bronze stuff really is the fundamentals, and we're going to start with our Git branching model. Now for infrastructure work, we typically want this to be reactive, right? We need a model that's going to allow us to handle multiple streams of work. As much as we say we don't do context switching, we do context switching. We need to be able to deploy quickly as well. All right? Lots of things get asked of us. We have project work, we have BAU work, we have alerts going off. A few laughs in the room. Git flow is not the one for us, okay? If you're using Git flow, I'd argue you're doing it wrong. A favorite of sprint-based dev teams everywhere who will die on the hill of Git flow. No one here tonight, hopefully, but it's not the one. And the reason being is this mess. You commit it, you have a dev branch, you make your feature branches from dev. At some point you cut a release, that then gets pushed through to production. It just gets messy. Lots of overhead, lots of management. Not reactive, right? Things get blocked in the pipeline. Same with long-lived environment branches. If your workflow has long-lived environment branches, again, doing it wrong, doing it messy. I've worked in teams like this, and in theory, it works well. We have a staging branch, and we know exactly what's been deployed to staging. Until the day someone just makes that one little change on staging, doesn't put it back, and then we're all in all sorts of mess, and we end up flattening all our branches once a week, and it's just a waste of time. So my preference is GitHub Flow, or trunk-based development is also okay. Fast-moving, really reactive Git branching models. And if you've never come across this, really simple. We have a main branch. We create a feature branch from our latest tag. We'll make some changes, do some testing, get it ready for a pull request. Once that's been approved and merged, we'll merge it back in, cut a new release. Simple. We can move quickly. And we can work in parallel as well. So multiple feature branches happening at the same time. It's just really easy. Use this. If you're not using it, please start doing so. While we're talking about versioning, I think this is a really important topic that you should be doing. We've worked with teams. I think this week we spoke with someone who's just deploying commits and just like rolling commits out to environments, and there's no real control. It's hard without these tagged releases to know which set of commits build a feature. And if you need to roll back, it's a lot harder to do without these tag commits. I like using Semver, semantic versioning, as our commit, as our versioning standard. And there's 3 parts to this if you've not seen it. I'm sure most of you have. Most major software products are using Semver as their versioning system. The first number on there is the major version, so breaking changes that aren't backwards compatible. In the middle, we've got our sort of day-to-day changes, new features, which is our minor version, and patches for any sort of bug fixes. We use this in an infra world. So a couple of examples, a breaking change, maybe we've deployed the latest major Terraform release in our module. It's not backwards compatible. Minor version is just adding some new resources, making some changes, and patches are generally bug fixes or those small trivial fixes. So, with this versioning standard in at the top, those release numbers, it's really easy to see what's happened when, and we can also tell without any context and looking at the commits and what's going on, that jump from 128 to version 2 is a major change, and there's going to be some work for us to do to incorporate that. So it's really easy, gives us a lot of context without doing much work. Right, while we're talking about commits, I'd like you all to start using atomic commits. So atomic commits is the practice of creating small commits that contain one change and one change only. We bundle all of the pieces to make that change happen into a single commit. And the reason for that and why this is useful, there's multiple reasons, but this is what we don't want to see. Okay, we don't want to see a commit message that has multiple features in it. So sort of here, right? We've added feature 1 and feature 2 in a single commit. And then we do some bug fixes, and then because we've got it all working, we now add the tests in, right? And then we add some docs at the end. And why this doesn't work is if we need to roll back feature 1 for whatever reason, we can't do so because it's bundled in with the other features. So those atomic commits really help us. Just, all of the stuff for feature 1, test, documentation, all of that stuff is encapsulated in that one commit. Same for feature 2. We may do bug fixes, but that is a separate change, right? So we should be practicing that. Commit messages. This is a bit of audience participation. Right, I'm going to ask everyone to stand up, please. Come on, everyone on the feet. Give me an opportunity to have some water. Okay, so we stay standing if you've ever committed code to a repository. Good, okay. Oh no, 1. We've had 1 drop out, that's okay, good. Number 2, stay standing if you've seen commit messages like this in a repository that you've been working in. Oh dear, oh God. Number 3, stay standing if you've written a commit and published it like this. Shame on you. Shame on you all. You can sit down. This one is for you. Conventional commits. Okay? If this is the one thing you take away from tonight, please start doing this. Conventional commits is a public standard, really easy to implement, about how to structure your commit messages, adds lots of context in a really easy to understand format. So first up, we have our type. We define the type of change. This is a feature, a fix, it could be some CI changes, documentation. We then have the what, so what's changing, we can add that in there, and a description of what are we changing as well. So why this is important? It makes it human readable in a consistent way across our team. We're all working in the same way. But it adds some meaning as well. It tries to like nudge you in the way of adding meaning to commit messages. It's also machine readable, which is really useful to do some automation, which I'll come on to in a moment. And it's enforceable. So, we talked about our pipeline starting to drive standards and drive quality. Because we've got this pattern, we can start checking for it and making sure that people are adhering to it. So here's an example. We're adding a new feature to our RDS instance. We're enabling multi-AZ mode. Really easy to understand what's going on. I don't have to go look at the code. We're adding a fix to a security group, removing an incorrect CIDR block rule. Or we're adding some tests to our pipeline. It's a CI type change. Okay, so really easy when you're looking at that Git history. Really easy to understand what's been going on since you last made some changes. Now, it takes a little bit of getting used to build that out. But there's a nice little tool called Committizen which will help you do that. So you run git cz rather than git commit. It pops up a menu. You can then just select your types, and it prompts you for the right bits. Okay, really useful when you're getting started. As soon as you get used to it, you just never look back. Now we talked about making these commits machine readable, and we can start to build our automation around these commit messages. So this tool here, Semantic Release, is a fully automated release management tool. What it does, it will, when you commit your changes and merge your pull request, it works out the difference between the last release and what you've added in. It has a look at all those contexts, all those types, and it works out what is the next version number that we need to publish. Does it all for us. It will then handle publishing the release. It will then handle Git tagging, and it will also automatically create release notes for us. Now that's really useful. We've found especially if you're working in organizations with change management processes, because you can take these release notes that are automatically generated and you can just plug it into your change management, okay, for sign off and all that sort of stuff. Really, really handy. And it just makes it easy. Anyone coming to use your repository, that documentation is just happening in a thoughtless way. I've not had to write docs for a long time with this stuff. Okay. It will work out, there's 2 bug fixes here. These are both dependency upgrades, but it recognized it was a breaking change, therefore it's created a new major release number. Easy. Okay, CI/CD. We obviously need a tool to power all of this work and all of this automation. Lots of options out there. I'm sure if we did a show of hands, there'd be lots of people using different tools. Hopefully no Jenkins. We need to get rid of Jenkins, team. Come on. It's time for this to go. We use a lot of GitHub, so GitHub Actions is the logical choice for us. What I do like about this is the marketplace, lots of plugins, lots of things we can just get off the community, get into our pipelines, get going quickly. An example of that is this plugin here, which checks our pull requests for conventional commits adherence. So if we're going to start powering our automated releases from our commit messages, we need to make sure that our commit messages are right. So we're going to put a step into our pull request step that will check and make sure before it goes to our release process. So let's add those two tools into our GitHub Actions, and then we'll put together and have a look at the pipeline end to end. So we're going to start. We've checked out and cloned our repository. We're going to create our feature branch using our GitHub flow methodology. We'll then make our changes. We'll do some testing. That iterative loop there. If it doesn't work, we keep making changes, making testing until it does. Then we're going to commit our changes to our repository, our local repo anyway, our local branch, and we'll do that with Git Committizen and the conventional commit standard. We'll then create our pull request, which automatically runs our pull request job. That's going to run the conventional commit check. Once that then goes to human approvers. I think that's still really important, for knowledge sharing and sort of training and such. We then merge it once we've got that approval, which runs our release job, and we can then deploy it to our environments. Now, options here, some teams we work with deploy to dev and then progress through. Some allow direct deployments from that version release in GitHub to any environment. That's up to you. I don't really have an opinion on that. Both work well. Okay, we've got our basic pipeline. We'll move on to Silver. We'll start adding some tools that makes our life a bit easier and also drives up that code quality. Okay, and the first, if we're using Terraform, there's a set of Terraform tools that we can just deploy into our pipelines and get going straight away. So Terraform will format our codes to a standard. I don't even know in format 2, it just does it, and we all work in the same way, so that's fantastic. Really useful because then it means we're not reviewing different formatting changes when we do pull request reviews. So everyone just needs to work the same way. We've got validate, which will check the local config, make sure your stuff will actually run. We then add tflint as a first pass of code analysis. We typically use it for checking for deprecated resources, unused variables, making sure the code is doing what we want and nothing extra. And then Terraform docs, so another tool that will automate our documentation creation for us. So this in the pipeline will create and spit out docs for Terraform modules. It's really easy. It shows what versions our users need. We list all the inputs automatically and the outputs. Makes it very easy for people to consume our stuff. Next, we'll talk about static code analysis, really important step in any pipeline. Our favorite one that a lot of our clients use is Checkoff. There are others available. This is so important. Checkoff's great for Terraform, Kubernetes, Helm charts, CloudFormation, I think, Azure Bicep, all sorts of stuff. And what it does is it will scan your Terraform codes in this example. It will make sure that you're not doing silly things, right? I temporarily just put my key into the code while I was testing, and then I did a git add everything, and now it's in the branch, right? It's going to stop you doing this stuff. It's going to stop you making mistakes. It's also going to make sure that we're adhering to resource requirements. So if I'm deploying a database, I think this is, we need to define the storage encrypted argument, and we're not doing so. So it's checking that for us early on. And third, it's going to give us best practice advice around security. So here I've opened up a rule to allow SSH from the internet. Generally not the best thing to do, but it may be a valid, there may be a valid reason why we need to do that. And if so, we can add in specific exceptions to this resource to bypass these checks. But that's an intentional step. We're not doing this by accident. Okay? So it's going to check all of this stuff for us, make sure we're not making ourselves look silly. So we're going to add those into our pull request step, and that will run when we create our pull request. Now, it's all well and good having these checks at the pull request stage, but for me that's a little bit too late in our pipeline. We should be doing this earlier on, as early as possible, that whole shift left methodology. And there's a couple of ways we can do that. So IDE plugins, set up a proper development environment that is not Vim. Who's using Vim here? Yeah, no. Set up a plugin, set up an IDE, get some extensions set up, and get it doing the work for you. So an example here is the Terraform stuff in Visual Studio, for example. We get it to, whenever you save a file, it will do the format. So I never have to run the format command ever again. It's done automatically. Same with validate. We can set all these things up to run as actions in our environment. The next one is pre-commit. So if you're not using pre-commit, please go add this to every repo that you can access. This is a fantastic tool that will do all of these checks for us before you commit code locally. So before you commit it to your local branch. And how it works, we put a pre-commit config file into our repository. It has all of the checks in place that we've talked about so far. And then when we clone our repository, we set up a Git hook just by running the pre-commit install, and that will intercept our Git commit commands and run these tests every time we try and commit code. Super useful, has saved my life many a time. So here's an example of what a good test looks like. I'm making a commit at the top, and rather than it just committing the code, it will run all of our tests, and all of them have to pass, unless there's no files, JSON files, there's no JSON in this example. And all of those have to pass before it commits the code locally. So I cannot continue in my pipeline until this happens. Next, deploy jobs. So we sort of skipped over this in the bronze pipeline. There's a couple of ways of doing this. A lot of our clients, they do something like this. We can have a couple of inputs where you can input your version number, your tagged release, and the environment you want it to go to, and it will just run Terraform plan, Terraform apply. But a friend of mine has successfully rolled this out, and I thought it looks quite neat. I've not personally used it, but really good feedback on Atlantis. And what this does, you can plug it into your pull request mechanism and use these commands to interact with deploying. So Atlantis plan does a Terraform plan, Atlantis apply does a Terraform apply. What I like about this is that your pull request becomes almost like a record of what's happened, and the conversation, if you will, and you can see when it was deployed, what happened, who did it, all that sort of stuff in one place. Really, really nice tool. So we'll have a look at our pipeline. So we're going to add our IDE plugins in there to help our local development environments. We're going to add pre-commit in when we do our commits. That's going to check our code, as we talked about. We're going to start building out our pull request stage, really getting into good checking of our changes that are going on. And everyone's working in the same way now. We can't bypass these things because we're checking at the pull request stage. Now it's important to have this, even though we're doing it early in pre-commit, it's also worth doing at pull request stage, because some naughty developers, and I'm sure there's some of you out there, do sometimes skip past those pre-commit checks. Yeah, I've got a hand there. It happens, right? Is that you, Matt? Boo. So we're going to check, right? We're going to ensure the quality control is our pull request stage. Super important. And then we'll do our deploys with Atlantis is a good option here. Good. Right. This is where we want to get to, our gold standards. Now this isn't really a tool that fits into the pipeline, but I thought I'd mention it. TFenv is a nice utility you can use to control the Terraform version you have on your machine. It's super useful if you work in a large organization, you're working across many repositories, easy to switch, you don't have to manage brew and all that sort of stuff. We just tell it to install a version, we tell it to use a version, away we go. Now that's all good if you know the version, but if I'm working in a client who has many Terraform modules, some clients like to do one module per repository, those versions do sort of age over time. So the real power in this comes with a Terraform version. You can put that into our repository and tell it, and then when I check out this repo, I can just do TFN views, it works out what version I need, away we go. Okay? So super useful. We shouldn't be evening it. We should, as part of it, create a commit to move that forward, but that's a different story. But really useful if you're working in big organizations. Next up, a system called Danger. We started using this in one of our clients. Actually found out that it's written by an old uni course mate of mine. What this does is it allows you to codify and configure your team norms into a step in your pipeline. So it allows you to automate all of those like common pull request, admin-y type tasks that you typically have to do. You know, oh, have you thought about adding this file? We always add a docs file or whatever it is. All of that can be checked and automated with Danger. So here's an example. This one's set up to do our conventional commits checks. It's also encouraging some best practice. So commits that change more than 250 lines of code should have a longer description in the commit body. Fab, okay? So it's nudging our sort of people in the right way, starting to drive that quality. Now, I really like this, especially if you have like junior members of your team. You know, if you're a senior engineer and the pull request stuff is on you to always pick up. You know, what I found historically is a lot of admin stuff first. It's like, oh, just go back and fix this before we get into the weeds of the change. So this will do that for you. It saves you a lot of time. Definitely recommend getting into your repos. Terraform plan, we touched on this briefly with Attendees, but I like that you can just plug this into your pipeline and it will print the results of a plan before you get to the review stage. So what we're doing here is we're starting to add more and more context about the pull request for our people who are going to do reviews. That's going to speed up our team and make, you know, the dependencies are less, the time taken to do pull requests, the cycle starts to get less and less. It's really easy for me as a reviewer to come here and see what's changing. All right, we're adding a new Lambda function, and that's right. So I know if there's any extra code in there that's not related to a function, start questioning. Infra cost is another one that we our clients really love. Okay, and it's, you know, this is not new news, but we see so many people not using it. All right, so this is a screenshot from a repository, and in this change that one of our consultants did, he saved the client $297 with that change. Fantastic, right? Who's not going to be happy with that? It's a shame he then added $6,100 in the next change, right? But you know, this is useful because as a reviewer, I'm going to see that and go, hold on, why are we adding 80 grand a year into this spend? Is this intentional, or has somebody just typed the wrong instance type in here? Okay, so really useful, adding this context into our pipeline, automatically making it much more easy for people to get things through. So let's bring those together with our gold medal pipeline. We're going to add TFM into our local environment, really useful. We're going to add those tools into our pull request check as well as into pre-commit. So we're doing those simultaneously. And then, you know, that allows us to get this code through this pipeline into our environments quickly, robustly, and we're making sure that we're delivering quality every single time. Okay? Now that's not the end, but this is where we should be, right? This is what it should feel like when we're doing our deployments. Looks easy, right? A load of complex steps that look super easy. So what's next? A few things we're looking at and working with our clients on. So building local stack into the pipeline, especially that local testing, really great. You know, have a local AWS environment in a container. Adding unit tests for Terraform. You know, we should be testing this stuff automatically. In policies and sort of controlling those through our pipeline with open policy agents. And then I came across this at a talk, I think it was DevOps Days. Somebody mentioned there's a standard called conventional comments. And this is really interesting. So we talked about the commits where we can add the context, but you can also do it in your comments. So not every comment is the same. We may just want to make suggestions for the future, and we're not asking for change, but this is a really useful way of categorizing those and structuring those to make sure people understand the context in which we're recommending change. If you want a list of these tools, please feel free to email me. I know I've gone through that very quickly. I'm happy to send these over as a list, and I can share the deck with you. But that's it from me. Thank you very much.
Great stuff.